Good morning and once again welcome to my YouTube channel, Pearson Edexcel International Maths by Mr. Kamotho. And in this one, having introduced ourselves to numerical methods and having understood example 1, I want us to go directly to example 2 and understand some stuff there. And we are told that the graph of the function fx is equals to 54x cubed minus 255x squared plus 309x minus 140 is shown in the diagram. And let's just put the diagram here so that we can see what we are talking about. That is 1, and I want to make it larger. This is, let me say this is 1 and this is 2. This could be half. This could be 1.5. So that we may have that graph that looks like something like that. And we have y is equals to, or rather fx, y is equals to fx, which is 54x cubed minus 225x squared plus 309x minus 140. We have such a statement. Now we have the y-axis there, and of course we have the x-axis there. We have 0, and we have, of course, -1, and we have a 1 there. Now, a student observes that students observe that f1.1 and the function of 1.6 are both negatives, and states that the function has no roots in the interval 1.1, 1.6. It has no root within that interval. Well, what do we need to say? Part A, we are told that as students observe that the function of 1.1 and the function of 1.6, which we could say 1.1 is here, the function is negative. We could say 1.6 is here or here, it's still giving us negative. Both of them are giving negatives, and therefore he concluded that the function does not have root between these boundaries. Part A, explain by reference to the diagram why the student is incorrect. Explain by reference to the diagram why the student is incorrect. Well, if we state that 1.1 is here and probably 1.6 could be there where the diagram is, of course we could be having at least 2 roots. The diagram shows there could be, if this is 1.1 and we could be having 1.6 there, then the diagram shows the graph cuts the x-axis at least twice, when x is between 1.1 and 1.6. So the students could be incorrect. The students could be incorrect. The students could be incorrect. And we have heard that The diagram shows the graph cuts the x-axis at least twice because we have seen this is 1.1, this is 1.6. It could be it cuts the x-axis there and the x-axis there. So at least twice when x is between 1.1 and 1.6. Therefore, the students could be incorrect. That is our statement. But let's go to part B of the question. Calculate f, the function of 1.3 and the function of 1.5, and use your answer to explain why there are at least 3 roots in the interval f 1.3. We need to calculate that, and the function of 1.7, and explain why there are at least 3 roots in the interval 1.1 x 1.7, and x is supposed to be greater than 1.1 and less than 1.7. Before we can even go to these limits, let us first of all talk about the function of 1.1 itself. If we substitute the 1.1 in this function, 54 1.1 cubed minus 225 1.1 squared plus 309 1.1 minus 140, we are going to realize something to do with negative 0.476. Please note the existence of negative, and again verify whether our calculations is right. After there, because we are told to verify to calculate the function of 1.3, then we go to f 1.3. If you substitute through the same, you are going to realize f 1.3 is 0.088. This is going to be 0.088. Something changes the sign there. What about f1. Let's talk about f1.5, because we are told to substitute. This is 1.5, for example, by the way. So it's important to note f1.5, 1.5. Then the function is going to be negative 0.5. Finally, if we have the function of 1.7 through the same routine as this one, you will verify that we are going to have the function giving us positive 0.352. Yes, what can we say about this? Let's go back to the diagram. When x is 1.1, we can even have an enlarged diagram here. We can we can just ignore and say we are coming from far. This is 1 and this is a 2 for that matter. When x is probably here 1.1, the value of the function gives us a negative value there. This is f 1.1. It's there. When x is 1.3, this is 1.1, 1.2, 1.3, let's say 1.3. The value of f 1.3 is positive. This is f 1.3 on the positive side, which is easily 0.088. When x is 1.5, could be 1.5, then we have a negative number, which is negative 0.5 somewhere there. So this is f 1.5, negative 0.5. When x is 1.7, let's say 1.7, then we have 0.3 something. This is f 1.7. So if we were to if this graph was continuous, and it is, it must be coming from this particular point, going there, coming here, and of course going there. So we can already see that it has at least 3 roots, and that is what we are supposed to show. Yes, there are at least 3 roots between 1.1 and 1.7. Hence, we can say hence shown. And that is exactly what we were to show. All right.